Okay, guys, Chapter 9, Lesson 7, Puzzle Problems. There are three kinds of word problems that you'll see in this section. Digit problems, age problems, and fraction problems. Now, the digit problems are the first kind we're going to look at, and in order to understand how to work these digit problems, you have to remember how our number system works. So suppose I have the number 51. 51 is actually 5 times 10 plus 1 times 1. 73 is actually 7 times 10 plus 3 times 1. Let's do one more. 148 is actually 1 times 100 plus 4 times 10 plus 8 times 1. The reason I need you to remember that is because what if I say the sum of the digits of a two-digit number is 8? Okay, so we know two digits. So let's call this one the tens digit and this one the units digit. Now, these two numbers, so like 62, 6 plus 2 would equal 8, or 53, or 44, or 71, or 17. You get the idea. The digits add up to 8. So how could we show that with variables? Well, what we'll say is the tens digit plus the units digit is equal to 8. Okay? Now, what if I say that the original number is worth 14? Well, you have to, or what if I say that this number is worth 14, then you'll have to remember that the tens digit times 1, or times 10, excuse me, the tens digit times 10 plus the ones digit times 1 is equal to 14. This is where people get tripped up. Let me rewrite it. The tens digit times 10 plus the ones digit times 1 is equal to however much the number actually is. You can't just put this is equal to 58 if the number was 58. Do you know why? Because TU in algebra means T times U. This means 5 times 10 plus 8 times 1. So in order to say the number is 58, with variables, we have to say the tens digit times 10 plus the ones digit times 1 is equal to whatever number we want, 58, 15, 14, whatever. Okay, so here's a kind of a problem that we'll be doing with digits. The sum of the digits in a two-digit number is 12. Okay, the sum of the digits. So we're going to say that T is the tens digit, U is the ones digit, and those two numbers have to add up to 12. Remember, that's like 93 or 39 or 66 or can't do 20 or 48 and so on. Multiple options here. That's why we don't know what it is. The sum of the digits is 12. Now, the new number obtained when the digits are reversed. Okay, wait a minute. How much is this number going to be worth? Well, it's going to be T times 10 plus U times 1. This is the original number. Now, what if we reversed the digits? Then that would be, so instead of looking like TU, if we reverse it, it'll be UT. And so then we'll have to do the U times 10 plus T times 1. Hey, buddy, how are you? Plus T times 1. And that'll be the reversed number. Okay, so it says, okay, so if you reverse the number, then you have to multiply the units digit times 10 and the tens digit by 1. So that's reversed. An example would be 53 and 35. So the numbers are reversed. And the way that you would show that with variables is here's the original number, here's the reversed number. So it says, the problem says, the sum of the digits in a two-digit number is 12. It took care of that up here. The new number obtained when the digits are reversed is, that's equal sign word, 36 more than the original number. So let's write the equation. The value of the switched number is 36 more than the original number. Okay, so now we've gotten equation 1 up here and equation 2 with a t and a u and a t and a u. Now we need to simplify this stuff so we can actually solve it. Let's go ahead and do minus 10u, minus 10u, minus 10t, minus 10t. So we'll have negative, well, let's go ahead and actually just minus the t over there too. Put it all over there. Minus t, minus t, minus 36. I didn't do this very elegantly here. So negative 36 is equal to, this is all gone, 9t minus 9u. Okay, let's divide everything by negative 9. And so what we'll have is 4 equals negative t plus u, or a little bit cleaner looking, 4 equals u minus t. Now combine that over here with our very first equation from the top. T plus u is equal to 12. Now we can add those. 2u equals 16, u equals 8. So the ones digit is 8, and so the number has to be 48, because we said if the ones digit is 8, the tens digit has to be 4, because 4 plus 8 is 12. So the number, the tens digit's 4, ones digit's 8, the original number is 48. Alright, that's a digit problem. So we learned how to do digit problems. Now there's an age problem. Let's talk about how to do one of those. So here's Mimi. She's a fine young lady, and she is 4 years older than Ronald. Okay, so here's Mimi and Ronald. Now Mimi is 4 years older than Ronald. So there's one equation. Now here's a weird, you have to kind of think for a minute, because 5 years ago, so how old was Mimi 5 years ago? 5 years ago, she was twice as old as he was. So how old was he 5 years ago? Well, minus 5. So 5 years ago, you got a minus 5 from Mimi and minus 5 from Ronald. 5 years ago, she was twice his age. So we have now and 5 years ago. Mimi is 4 years older than Ronald. And 5 years ago, she was twice his age. So now find the age now. So we have M and R we're looking for. Okay, well, we're going to simplify this equation. M minus 5 equals 2R minus 10 plus 5 plus 5. M equals 2R minus 5. Okay, let's go ahead and do substitution here. 2R minus 5 is equal to 4 plus R. Minus R, R equals 9. So Ronald is 9, and Mimi is 4 years older than him, so Mimi is 13. We figured out their ages. And let's check it. 5 years ago, Ronald would have been 4, she would have been 8, she would be twice as old. We got it. That's how you do an age problem. So we did a digit problem, an age problem. Now there's a fraction problem. Let's look at those. In this kind of problem, they're going to be talking about the numerator and the denominator separately. So remember, on a fraction, the numerator is on the top, the denominator is on the bottom. If the numerator of a fraction is 3 less than the denominator, the numerator of a fraction is 3 less than the denominator. Now, if the original fraction has the numerator increased by 1 and the denominator increased by 1, then the resulting fraction will be 3/4. So now you can't just do -1 and get 2/3. That doesn't quite work because remember this is a simplified. It could be 6 and 8. So we want to find what the numbers are using our system of equations. Okay, so in order to simplify, so we have one equation and two equations. It said the numerator was 3 less than the denominator, and if you bumped up the numerator by 1 and the denominator by 1, we'll have 3/4. The question is, find the original fraction. Okay, so let's take our second equation and simplify it with cross multiplication. So I'm going to have 4 times n plus 1 equals 3 times d plus 1. 4n plus 4 equals 3d plus 3 minus 3 minus 3. 4n minus 3d equals -1. I did a little bit in my head there. I hope that wasn't too fast. Okay. Now I've got my first equation was n equals d minus 3. I'm going to go ahead and substitute n. So now I've got 4 times d minus 3 minus 3d equals -1. 4d minus 12 minus 3d equals -1. d minus 12 equals -1 plus 12 plus 12. d is equal to 11. Okay, so now we know what the denominator of the original fraction was. It's 11. Now how do we find the numerator? Well, the numerator is equal to the denominator minus 3. So 11 minus 3 is 8. Our original fraction is 8/11. And you can plug the numbers back into our original equations and you'll see that it works. 8 equals 11 minus 3, and then 8 plus 1 is 9, divided by 11 plus 1 is 12. So 9 divided by 12 simplifies to 3/4. It works. So we did it. Good job. Okay, so there are 3 kinds of problems. Digit problems, remember the TU stuff. The age problems, and so it's going to be like a now age and a then age. And then fraction problems with numerators and denominators. Okay, let me know if you have any questions.